All right, for number 2, let's find all 6 trig ratios for angle G. So I drew a little marker there. I also can draw my little buddy. He makes me happy. All right, so again, we always want to start off with sine, cosine, and tangent. That's just what we've grown used to for a lot of us. So with sine of G, sine of G, we know it's going to be opposite O over hypotenuse H. So which one is opposite, which one is hypotenuse? In relation to where we are standing, the side opposite is this piece over here, 12. So I can draw an O for opposite. And hypotenuse is this side here because it is across from the right angle. So we would say 13 is the hypotenuse H. So we get the sine of G is opposite over hypotenuse, or 12 over 13. Now cosine of G is adjacent over hypotenuse. So adjacent to G, or adjacent to where we are standing, is this 5 here. So we get cosine of G is adjacent 5 over hypotenuse 13. And finally, the tangent of G is going to be opposite 12 over adjacent 5. Okay, so notice here I didn't write SOHCAHTOA because we should be at a point where we can remember how to set up these ratios. Okay, if you're not quite there yet, I do encourage you to use SOHCAHTOA to remind yourself. But if you're good, if you're past that, great. You know, efficiency, it's nice to be efficient in math, so that's okay. All right, so we found our original 3 trig ratios. Now we can find cosecant, secant, and cotangent. So let's do that. So the reciprocal of sine, that will give us cosecant. So, sorry, I always write CO. It's supposed to be cosecant is CSC of G, in this case, because that's our reference angle, is the reciprocal of 12 over 13, so it's 13 over 12. Now next, the reciprocal of cosine is secant. So the secant of G is 13 over 15. Oh, sorry, 13 over 5. I read that wrong. And finally, the reciprocal of tangent is cotangent. So we get the cotangent of G is equal to 5 over 12. 5 over 12. And there we go. Okay. So let's do one more here. Let's scroll down to number 3. Okay. So for number 3, let's assume we have X as our reference angle. And again, I'm just choosing a random angle here. I just decided to choose X, so that's where we're going to stand. Yay. All right. So again, let's identify sine, cosine, and tangent. So the sine of X is equal to opposite over hypotenuse. Opposite from where we're standing is 9. So I can write that in. Here's O. And the hypotenuse in our triangle is across from Y, or across from the right angle. So it's 41 is our hypotenuse. Okay, so the sine of x is 9 over 41. Now the cosine of x is going to be adjacent a over the hypotenuse. Adjacent to where we're standing is this 40 right here. So we can write cosine of x is 40 over 41. And finally, the tangent of x is going to be opposite O over adjacent A. So it will be 9 over 40. Awesome. So now let's find the reciprocals of each. So the reciprocal of sine of x will be cosecant x. So CSC x is equal to 41 over 9. The reciprocal of cosine is secant of x is equal to 41 over 40. Finally, the reciprocal of tangent is cotangent. So we get cotangent of x is equal to 40 over 9. Okay, so what we're doing here is going to be the main focus of today's lesson. Okay, what you want to be able to remember is which trig ratio is the reciprocal of which. Okay, so let's sort of look at these a little bit more closely. Now, identifying that cotangent is the reciprocal of tangent is pretty straightforward because cotangent has the word tangent in it, so you're like, oh, okay, I see how these two could be related. But a lot of times people will mistake cosecant for secant and vice versa. So the way that I like to remember it, and I encourage you to find your own ways to remember these things too. But the way I tend to remember it is notice that the reciprocal of sine starts with a C. So S and C, these two will be different. Whereas the reciprocal of cosine starts with an S. So I know that the opposite of cosine will be secant, right? I don't know why, but in my head I feel like knowing that those two letters do not match helps me remember that those will be reciprocals of each other.